You know, for as long as we've been looking up at the night sky, the moon has always been there, that familiar silver disk. But what if I told you that almost everything we thought we knew about it, that it's dead, dusty, and distant, is just plain wrong? Because a whole wave of new discoveries is completely rewriting the book on our closest celestial neighbor.
Yeah, this is probably the moon you remember, right? The one from the textbooks, beautiful for sure, but also kind of inert. An isolated world, and for decades, the scientific consensus was pretty simple. The only real connection between us and the moon was gravity. And that was pretty much the end of the story.
Well, not so fast, because that story is nowhere near finished. In fact, modern science is basically tearing up that old script. We're now seeing a moon that's more dynamic, more complex, and way, way more connected to us than we ever imagined.
So here's what we're going to dive into. We're looking at 4 huge revelations that are changing everything. We'll kick things off with a totally unexpected link to our own planet, then explore its wild split personality, unlock some amazing secrets in old rocks, and finally, check out who's pioneering this new lunar era. Let's get to it.
All right, let's start with that whole idea that the moon is just out there, all on its own. Turns out that's not really true. Recent research has found a direct physical link between Earth's atmosphere and the moon's surface, and this connection goes way beyond just gravity. I mean, this is a fundamental shift in our thinking. We used to picture the space between Earth and the moon as just empty, a void. But we now know it's more like a pathway, allowing particles from our own atmosphere to make the nearly quarter-million-mile journey and actually settle on the lunar surface.
Scientists have a name for this, atmospheric transfer. But what it really means is that the very top layers of our atmosphere are kind of leaky. Lighter elements, especially oxygen, can escape, journey across space, and get deposited right onto the moon's soil. Our planet is literally dusting the moon with bits of itself.
And this isn't just some cool trivia, It has huge implications. It helps explain why we're finding certain elements in the lunar soil that, frankly, shouldn't be there. And as we plan for permanent bases, these very elements could become critical resources. It totally redefines the moon as part of a shared Earth-Moon system.
So this growing connection to Earth is just the beginning. We also tend to think of the moon as just a uniform ball of rock, right? Well, new data reveals it has a dramatic split personality with 2 fundamentally different sides.
A lot of this new insight is coming from China's incredible Chang'e 6 mission. By analyzing samples and data from the far side of the moon, the side that never faces us, scientists have uncovered a massive difference in its internal structure.
The core finding is a pretty stark temperature difference. Deep down, the near side of the moon, the face we always see, is significantly warmer. The far side, on the other hand, is much, much colder. And this isn't just a surface detail, it strongly suggests the 2 halves have had wildly different geological histories.
This discovery brings up a huge question that really challenges our basic models. I mean, if the moon was born from a single massive impact, like we think it was, then why did its 2 sides evolve so differently? It's a mystery that hints the moon's formation and its volcanic past are far more complex than we ever knew.
What's really amazing is that some of the most exciting new discoveries are coming from our oldest evidence. I'm talking about the lunar rocks brought back by the Apollo missions over 50 years ago. We thought they had told us their whole story, but it turns out they're revealing brand new secrets.
Just think about the journey these rocks have been on. They were collected half a century ago and carefully preserved, but the technology to really analyze them just didn't exist back then. Now, with today's advanced lab techniques, we're able to peer inside them and unlock chemical secrets that were hidden in plain sight this whole time.
So what are we finding? Well, hidden deep inside these rocks, scientists are identifying mineral compounds we never thought could form on the moon. They're finding unique sulfur signatures that are like fingerprints of ancient volcanic eruptions. All these clues are giving us a much clearer picture of the moon's fiery past.
The big takeaway here is pretty profound. The moon wasn't just a simple, geologically dead world after it formed. No way. It was a place with a complicated, evolving chemical history, and we're just now beginning to understand the richness of that past.
All of these new discoveries are fueling a complete transformation of who is going to the moon and why. See, lunar exploration is no longer just the domain of government space agencies. We have fully entered a new commercial era.
The year 2025 marked a massive turning point in this story. This was the year that private enterprise really and truly arrived on the lunar surface.
A company called Firefly Aerospace achieved the first fully commercial soft landing on the moon, successfully delivering scientific payloads for NASA. This was a historic moment. It proved that private companies could operate in deep space, and the data they're gathering on the lunar soil, or regolith, is absolutely vital for planning future robotic and human missions.
And the momentum is only building. The next major step in humanity's physical return to the lunar environment is already slated for 2026.
That's when NASA's Artemis I-2 mission is expected to launch. Now, this crew won't be landing, but they will be the first humans to orbit the moon in decades. The mission's goal is critical: to test all the deep space systems and human endurance needed for the long journey, paving the way for a permanent human presence. So when you put it all together, you see this whole new lunar ecosystem taking shape. It's a balanced partnership between four key areas. You've got foundational government science, innovative commercial transport, the long-term pursuit of lunar resources, and the ultimate goal of human habitation. No single piece is more important. They all have to work together to make the moon a bustling hub of activity.
At the end of the day, it's clear the moon is no longer just that poetic light in the night sky. It's an active, complex world. It's environmentally connected to Earth, it's geologically diverse with its two distinct faces, and it is rapidly becoming humanity's next great frontier.
Perhaps the best way to think about it is this: the moon isn't a separate story. It's the next chapter in our own. It's a world that not only gives us a glimpse of our shared past, but is also lighting the way for our future in space. And you have to wonder, what other secrets is it waiting to tell us?